Hi everyone, my name is Amitesh, and in this video we're going to talk about domains of functions, finding the domain of a function. Now in previous videos I've talked about this topic as well as what are functions, and all relevant videos have links down in the description below, but each video is designed to be as accessible as possible. In this video we're going to focus on the absolute value and finding domains of functions where the absolute value is thrown in. Okay, so this adds some extra layer of complexity, but in math everything can be broken down into steps, and that's what we're going to do in this video. So let's dive right into it. So finding the domain of a function. So we're going to talk about finding domains. Now the main thing to keep in mind when finding the domain of a function is that you cannot take the square root of a negative number and you cannot divide by 0. Those are the main rules. Okay, so we need to keep those in mind, and we need to think about when we're dividing by something, we want to make sure that something is non-zero, and when we're taking the square root, we want to make sure that something is at least 0. Okay, so let's think about the following example. So I'm going to write down an example with the absolute value. So I've done videos on the absolute value before, links are down in the description. This is also designed to be more practice with those. So one example we can start off with is the following: 1 over absolute value of x minus 5, find the domain of f. Okay, so that's question number 1. Now the first thing to keep in mind is that we cannot divide by 0. There is no square root here, so we don't have to worry about that. But we cannot divide by 0, that is not defined. So what we are dividing by in this problem is we're dividing by absolute value of x minus 5. And we need to figure out when an input x gives a valid output. So when is the absolute value of x minus 5 not equal to 0? Okay, so we want, I'm going to write this in the following, we want absolute value of x minus 5 to be non-zero. If that's true, then x is going to be in the domain, because you can divide by whatever it is, absolute value x minus 5. Now in other words, if we solve the equation absolute value x minus 5 equals 0, then we can consider all the x's that aren't solutions, and that will be all the numbers in the domain. So we can think of this as just solving an equation. So we're going to solve absolute value of x minus 5 is equal to 0. Now the main rule to remember with the absolute value, whatever definition you've seen, the absolute value of x is the distance from x to 0. So the absolute value of minus 3 is equal to 3, because minus 3 is 3 away from 0. So actually I'm going to draw the number line here just to show you. So if I have numbers like this, the absolute value of minus 3 is 3, distances are always non-negative, and the absolute value of 2 is equal to 2. Okay, so 2 is 2 units away from 0, minus 3 is 3 units away from 3. That's what the absolute value is. And now if we solve absolute value x minus 5 is 0, we're adding 5 to both sides of the equation. Remember, when you solve an equation, always isolate the x part. Okay, so absolute value x is one entity. Okay, we have to just isolate that, get absolute value x is 5, and now what are the values of x so that its distance to 0 is equal to 5? Well, it's just going to be plus or minus 5, right? So those are going to be on the right of 0, you can go 5 units. If you're an ant on the number line, on the left of 0, you can go 5 units. So both ways you can go 5 units. This implies absolute value x is 5, so x is equal to 5, or x is equal to minus 5. That's going to be the solution. All right? So what is the domain of the function going to be? It's going to be all the numbers where they are not equal to 5 or minus 5, because that's when you're dividing by 0. Okay, so the domain of f is equal to all real numbers except minus 5 and plus 5. Okay, that's what the domain of the function is going to be. So you see, you've got some linear equation with the absolute value on the denominator, and we had to solve that linear equation to find the domain. So typically finding the domain of functions requires solving equations, because you want to exclude certain numbers, and that involves solving an equation. Let's do another example with the absolute value again. So I'm going to erase this all off, and this example is going to be pretty cool, because it's going to involve the square root and the absolute value. So let's dive right into it. And it's going to also involve solving an inequality with the absolute value. So I've talked about that in another video, And so we're going to do that in this video too in order to solve this domain problem. And this is how math kind of breaks up into these pieces, and they all kind of show up a lot. So once you've mastered the basic concepts, you can solve any problem by reducing it down to them. So let's kind of get this going, and my goal is to help you to master those concepts. So here we're going to write down another function, g of x. Okay, so g of x is going to be the square root of the absolute value of 2x minus 3 minus 4. Okay, that's what g of x is going to be, and we want to find the domain of g. Okay, so that's what we're going to do. So these are functions, I'm just writing them down. Okay, I haven't actually thought about them before, I'm just writing them down, but I know what I'm trying to do, which is I'm trying to now create a question where we have taking the square root of something, we want to avoid taking the square root of a negative number, right? That cannot be done because the square of every number is going to be always at least 0. So if you take a number that's negative, there is no number that can square to be it, right? The square of a negative number is always positive, the square of a positive number is always positive. Okay, so what we need to do is we need to avoid this thing here. We want to say 2x minus 3 minus 4 is at least 0. Okay, that's what we want. All right, so we want that. Now, how are we going to solve for this inequality? Well, again, the first step, if you haven't seen something like this before, always isolate the x part. Okay, the absolute value of 2x minus 3 in this case is what I call the x part. You cannot kind of simplify it, it's its own entity for the time being. So we just kind of keep it to one side of the equation. So we get 2x minus 3, the absolute value is at least 4 because you add 4 to both sides of the equation. Okay, so you get that. Now when is the absolute value of 2x minus 3 at least 4? So the way I like to think about this is always reduced down to the basic idea of the absolute value. The absolute value of something is its distance from 0. Okay, so if we are saying the absolute value of 2x minus 3 is at least 4, that means that 2x minus 3 is at least 4 units away from 0. It can be at least 4 units away from 0 to the right on the number line. So you've got 4 on the right of 0, and you've got negative 4 on the left of 0, and we know that 2x minus 3 is either going to be beyond 4 or it's going to be beyond minus 4 to the left of minus 4 or beyond 4 to the right of 4. So its distance, which is its absolute value, is at least 4. Okay, so we can split this inequality up into two inequalities now. We're saying that the absolute value, we're saying that we can remove the absolute value, and now we get something, it's sort of just a linear inequality. 2x minus 3 is greater than or equal to 4, or there are two possibilities, 2x minus 3 is less than or equal to minus 4. Okay, and we can now solve both the inequalities. Now, one thing I like to do is another way of thinking about solving these two inequalities. This is just a quick trick, is saying that, you know, absolute value 2x minus 3 is at least 4 is the same as saying that absolute value of 2x minus 3 is not less than 4. Okay, so if we figure out when the absolute value of 2x minus 3 is less than 4 and then take the other x's which aren't solving that, we can then get the solution for this. Okay, and why I do that is it's, as I mentioned in a previous video, you can kind of think of this in two steps. So for example, so let me just erase this. So what you can do is, I'm going to put this out in black. If we're solving absolute value 2x minus 3 is less than 4, which is the opposite of that, right? So 2x minus 3 is within 4 of 0. We can write this as negative 4 less than 2x minus 3 less than 4. That's kind of the range of values you can have on the number line to be a distance of 4 from 0, or less than a distance of 4 from 0. And now we can just solve this simultaneously. We can add 3 to both sides. So we get negative 4 plus 3 is less than 2x is less than 4 plus 3. Okay, so we've got that. And now we can then if you have a bunch of numbers and you add 3 to all of them, if the numbers are in sequence, you add 3 to all of them, they'll still be in sequence, right? Like if I have some money, you have some money, if we both get $3, you'll still have more money than me if you had more money than me to begin with. So we're going to have that. So we're going to have -1 is less than 2x is less than 7. And now we can divide by 2 on both sides. So we get -1/2 is less than x is less than 7/2. Now, the solution that we want is the opposite of that. That's when absolute value 2x minus 3 is less than 4. The opposite of that is absolute value 2x minus 3 is at least 4. And for this, we want to say the following. We want to say that what is the opposite of x being between -1/2 and 7/2? So you can draw it on the number line, okay? So you got 0, you got -1/2, and you've got 7/2. Okay, so if x is not in between this range, that means x is either less than or equal to -1/2, on this side, or it is greater than or equal to 7/2 on that side. Okay, so either, write it this way, either x is going to be at least 7/2 or x is going to be less than or equal to -1/2. Okay, so you could have solved those two inequalities separately as well. Doing it this way means you can do it in one go, right? So it doesn't matter. Either way is equally fast once you get the hang of it. So we've got x at least 7/2 or x less than or equal to -1/2. That's what we want. That's when our x is going to give us a value inside the square root that we can take the square root of, something that's at least 0. So now we've solved that, we can write out the domain. So what's the domain going to be? So I'm just going to erase this off. So the domain is going to be, let me do that in blue to kind of keep the consistency. So the domain of f, or the domain of G, is going to be all real numbers x such that x is at least 7/2 or x is less than or equal to -1/2. Okay, so that's going to be the domain of our function g. Okay, so that's the domain. Now I will talk about how to write this completely in mathematical notation in another video. Links are down in the description. In this video I'm just writing it out in English because the goal is to really understand how to find the domain, and then once you do, the symbolic explanation or symbolic expression comes next. Okay, so that's two examples, one with the reciprocal and where we couldn't divide by 0, and one with the square root where you cannot take the square root of a negative number, and both examples involve the absolute value, so it's practice with inequalities and equations with the absolute value. And I've talked about that in more detail in other videos, links down in the description as I mentioned. So thank you so much for watching. I hope you loved that video, and please leave a like and subscribe if you did. It would mean a lot to me and really help disseminate my videos to as many people as possible who would also be able to enjoy and benefit from the videos. So thank you so much. It's free as well to like and subscribe, so it means a lot. I know everyone asks for this, but it's just free, and it really helps also to keep you notified for new content, and also to keep help me. It means a lot as a support. So thank you so much. I'm super excited to see you in the next video, and even just watching this video has meant so much to me, and I really enjoyed making it as well. Check out my other videos on the absolute value, on domains of functions, on functions. Links are all down in the description. And leave a comment. If you have any comments, thoughts, or feedback, I'd love to see them. So leave a comment down below. I'm super excited to see you in the next video. Please take care, and I wish you all the best. Wherever you are in the world, whatever you're doing, I genuinely wish you the best, and I hope I've been able to support you by making these videos and sending you all my best wishes. So please take care, and I will see you soon.